This is standard ARCH.8.E.A.2.8.1e. The learning target is I can simplify radical expressions. A radical sign looks like a check mark and a division box. So more or less, if yours look like this, then here is a little tiny number just above the check mark called the index. You see the number 2 here, or 3 here, or 4 here. You can have any number, but when you're trying to find the root of a number, when you see a 2, we say, find the root of the number under a radical sign. So for example, 16 is under the radical sign, so you want to find the root. The root equals 4, because 4 times 4 equals 16. When there's a 2 here, we call that the square root. When there's a 3, we say the cube root. And there's a 4, we just say the fourth root, and so on. So going back here, we say the square root of 16 is 4. We want to know what numbers that are identical to each other will allow a product as seen under the radical. So usually this radical sign that has no index is equal to the radical sign with a 2. You will not see a little 2 because it is agreed that it is invisible. However, if we want the little number 3 with an 8 under the radical sign, you will see a 3. That's called the cube root. So just to sort of summarize, the little number here is called the index. The sign here that looks like a check mark division box is called the radical, or the radical sign. And the number under the radical sign is called the radicand. And by the way, 2 times 2 times 2 equals 8. So 2 is the cube root of 8. Some numbers do not have a perfect square. Then you must, at times, still find out if it is a rational or irrational number. For example, the square root of 2 cannot be written as a ratio that terminates or repeats, so it is irrational. Now what I mean by that is, what number times another number equals the square root of 2? That's what I'm saying. We don't have a number that when multiplied by itself will equal 2. Because the numbers that we would put here would not end, or they would not repeat. So because of that, square root of 2 is irrational. So the conclusion is, only perfect squares, that is a number multiplied by itself, have rational roots. All others are irrational. So for example, a perfect square would be 4 because its root is 2. 2 times 2 equals 4. A perfect square is 9, so its rational root is 3 because 3 times 3 equals 9, and so on. When you look at an actual square, not the best square, it's just a sketch, so you're allowed to be slightly imperfect. If you put a number that is a perfect square inside the square, you will see that the side lengths are the same, and those are the roots of a perfect square. So you can see this visually. Also, the square root of 1 equals 1. I should have covered that up here. And then the inverse operation of roots is exponents. So inverse, meaning opposite operation. So for example, the square root of 16 is 4, and then if you square 4, you get 16. So you're undoing it by a square root, and then you're bringing it back by squaring it. So when you see this radical with this exponent, your solution is really the same number that's the radicand. And here, the square root of 25 squared is 25. But what happens if you have the cube root of 8 squared? Well, we learned earlier that the cube root of 8 is 2. So then you would write 2 squared equals 4. So you can find the cube root and then square it. You will also see this written as a fraction or a fractional exponent. 8 to the 2/3. The 2 is the power, and the number on the bottom is the root. So keep that in mind when you're looking at a number with a fractional exponent. The top number, or the numerator, is always the power, and the bottom number is always the root that you're looking for in that problem. And that concludes this lesson.